Welcome to the sailor sheet. Today we are going to discuss Naval Arc 2 question number 9. Generally this come in question number 9, inclining experiment, or sometime it will come in the part A, 25 marks. So this is very simple type of numericals and you can easily score 25 marks. So there is theory part also and there is numerical part also. So we'll solve some past MMD paper also in this video, and we discuss also the theory parts so that you can easily score 25 marks. Okay, so inclining test, inclining experiment determining metacentric height of the ship. Generally, what is the purpose of this test? The inclining experiment is performed by the shipyard in order to obtain the kg of the ship in light condition. So this is performed by the shipyard when the vessel is ready to launch, and this is done by shipyard in the presence of class and flag is stated. So once this is known, the kg can be thereafter be calculated for any desired condition of the loading. The inclining experiment should be done when the building of the ship is completed or nearly is completed. What is principle? 2 or 3 long pendulum or rig on the center line of the ship, one forward, one midship and one aft. List is created by moving several known weight, usually 2 or 3. Result obtained by different pendulums are averaged. By knowing the deflection of the pendulum, plumb length, km, displacement including known weight and distance moved, initial GM is calculated. Calculated GM is then GM fluid for that condition. What is procedure of this test? The 2 or 3 long pendulum are rigged on the center line of the ship, one forward, one midship and one aft. The bob is immersed in oil or water to dump out oscillations. A horizontal pattern graduated in centimeters is fitted above the plumbs. Ideally 6 equal weights are placed on deck, 3 on each side at equal distance of the center line. The total of weight shall be about 1:50,000 of 1:500 of light displacement. Using dock crane, one weight is shifted from starboard to port after allowing shifting time from the ship to settle in the listed condition. The deflection of the pendulum is noted. The second weight is shifted from starboard to port and the deflection is noted. The third weight is also shifted and deflection noted. All the 3 shifted weights are then returned to their original position. Entire procedure is repeated for weight on the port side and deflection noted. Deep allowance must be made in all calculation for the weight placed on board for the conduct of the experiment. The weight and the distance moved should be adjusted such that the list cost is reasonably small. If the list is insufficient, the deflection would be too small, resulting in an accurate GM. If the list is more than few degrees, the consequent increase of Km would render inaccurate result. Now the question is also what is precaution you should take while conducting the experiment. So we have some precautions. Before the commencement of the experiment, the ship should be perfectly upright. A large stream should be avoided. The ship's initial GM should not be too small. There should be no wind. If this is not possible, the ship should behave heading into the wind. All mooring lines to be slack, gangway to be well clear of jetty, no other craft to be alongside. The depth of water should be enough to ensure that ship is freely afloat throughout the experiment. All portable beams, deck, rigs, ports, etc. to be in proper seagoing condition. Any loose weight to be secured. All personnel not directly connected with this experiment should be ashore. Those on board should stay on center line. Boilers are to be completely empty or full. As far as possible, all tanks should be fully or empty. If not possible, the value of efficiency should be noted. All bills to be dry, draft forward, aft and midship, and the density of water to be noted. Also the density of the water, you have to know accurately. Okay, all the person doing this experiment should wear the proper personal protective equipments. Okay, so all these precautions should be take care. And this is a pendulum which we need to put in oil or water to dump oscillation. Okay, so this is triangle. If you see this triangle ABC, tan theta is equal to BC upon AB, and in triangle MGG1, tan theta is equal to GG1 upon GM. Okay, so tan theta is common, so BC upon AB is equal to GG upon GM. So GM is equal to AB into GG1 upon BC. Now since we know that GG1 is equal to, since GG1 is equal to W into D upon displacement, so W into D upon displacement into AB upon BC. So this is formula of inclining experiment. Okay, now GM is equal to, what is AB? AB we have to call pendulum length, so W into D upon Do into pendulum length. Divided by BC's deflection. So our formula is this one. This formula we are going to use the numerical. Okay, what is W? Small w, weight shifted, port to starboard, starboard to port for the experiment. D is distance through which it is shifted. Capital W is final displacement. Okay, so we know the W, small w, we know the D, we know the total displacement. Okay, deflection we find out from the experiment, and pendulum length we know. So all we know, so that we can find out GM. And when we find out the GM, the KM is provided by the naval architecture, and we know the KM, we know the GM, we can find the light ship kg, which is required of this experiment. The whole experiment is find out the light kg of the vessel. Okay, now we are going to do some past paper, so that you will able to solve this type of numerical. Okay, for a displacement of 4000 ton, a mass of 12 ton is shifted transversely across the deck. A deflection of 75 mm in a plumb line of 7.5 meter was observed. If the km is 10.2 meter and the kg is 7 meters, find the distance through which the weight is shifted. Okay, so let's solve this. What is given in the question? Displacement 4000, mass of 12 ton, so small w is 12 ton, shifted across the deck. A deflection of 7, deflection is given here. Deflection is given 75 mm, so we need to convert in meters. All should be in 1 units, so 0.075 meter. Okay, plumb line is already given in meter. Plumb line is 7.5 meter. Km is given, kg is given, so you can write in the km is 10.2 meter, kg is 7.0 meter. Find the distance, that means D, we need to find D through which the weight is shifted. So our formula is, so first km is given 10.2 meter, kg we given 7 meter, So GM we can find out 3.2 meter. Now since we know that formula, GM is equal to W into D upon displacement into pendulum length divided by deflection. Now put the formula. GM is 3.2, we just calculated. D we don't know, we have to find out. 4000 into 7.5 divided by 0.075. The cross multiplication, 3.2 into 4000 into 0.075 is equal to 12 into D into 7.5. So we get 960 is equal to 90 D. So D is equal to 10.67 meter. Okay, so let's move to the next MMD question. An inclining experiment was conducted MV Hinship with all tanks and compartment empty except 28 ton each of diesel oil in the number 7 port and starboard. Tanks and also 12 tons each of fresh water in the twin deck drinking water tank port and starboard. When the inclining weight of 5.75 ton kg 10.2 meter is shifted transversely through a distance of 16.95 meter, plumb line is 8 meter in length, deflection 5 cm. So plumb line is 8 meter and deflection is 5 centimeter. So 5 centimeter we need to convert in the meters. Calculate the light kg and GM of the vessel. Okay, so in this type, if it is generally the question is coming like this way only. Okay, so there is procedure to do this. First we have to find out the GM fluid. First we have to find out the weight, final weight, then GM fluid, then we have to calculate the FSC, then we have to calculate the final kg, and then we have to find out the light kg, and then we have to find out the light GM. So this is a procedure. Okay, so if you remember this procedure and solve these 2-3 numericals, you are comfortable to solve this numerical. Okay, so let's solve this numerical. What is given in the question, we have to write in examination what is given, so that it is good impression for the examiners who is going to correct our paper. Okay, so small w is 5.75 ton, kg is 10.2 meter, deflection is 16.9, d is 16.595 meter, deflection is 5 cm, so we need to convert in meters. Plumb length is 8 meters. Okay, now from the MV Hinship particulars we need to find out the light ship. It is given in the first page. Also in the condition number 1 you find out the light ship displacement. Okay, condition number 1 MV Hinship particular, or the first page of where the LBP is given, you can find out the light ship displacement. 54998, this you have to remember, this is fixed, or you can find out from the MV Hinship particulars. Okay, now the number 7 port and starboard 56 ton. Drinking water twin deck port and starboard equal to 24 tons. Small w is given 5.75. Okay, never forget this small w, this is very important, otherwise your answer will become wrong. So small w is also we have to consider. So final displacement is equal to, we have to add all this. So final displacement 5585.55 ton. Okay, this is final displacement. Now for our formula is GM is equal to W into D upon displacement into plumb length divided by deflection. Put the value in the formula. 5.75 into 16.95 divided by 5585.55 into 8 divided by 0.05. So GM fluid we get 2.792 meter. Okay, now we need to find third step, FSC. So what is FSC formula? I into DI. Okay, now DB tank, 7 port, 50 into 0.88. Okay, this 50 we have to find out from the MV particulars. Okay, and 0.88 is the density, so we multiply and we get 44. 7 starboard is 33 into 0.88 is equal to 29.04. so we need to add this 73.04. Linking water tank port is equal to 37 into 1, so 31. Fresh water density 1, and the FSM we have to find out the FSM table from the MV particulars. Starboard side 42 into 1, so 42. Addition, so 79. Now we have to add the total FSM. $73.04 plus 79, so it's equal to 152.04. Now FSC is equal to FSM upon displacement final. So 152.04 divided by final displacement 5585.55. So our FSC is equal to 0.027 meter. Okay, now for the final displacement 55855.55, we need to find out the Km from the MV particulars. Okay, so GM fluid we already calculated 2.792 meters. FSC we are calculated 0.027. Now before we are going like this, Km minus Kg is equal to GM solid minus FSC is equal to GM fluid. Now we are going to opposite side, so we need to add. Okay, so add. So GM solid we get 2.819 meter. Now from the MV we have to find out the final displacements Km. So in that case I get 11.561 meters. Okay, so final Kg, Km minus GM solid, we get final Kg 8.742 meters. But we need to find out the light Kg of the vessel. So now we go by the moment method. So W, displacement, Kg, and vertical moment. So final displacement 5585.55, final displacement. The Kg is 8.742. Okay, this is given in the MV Hintship. This we calculate 8.742 from this here. Now 7 port is 28 ton, 7 starboard 28 ton, linking water tank port minus 12 ton, linking water tank starboard minus 12 ton, and the small W 5.75 ton. So we get light 5499.8. It should be 549.9 your light ship displacement. Put the Kg you can find out from the MV particulars. Okay, and the small W is given Kg in the question. So cross W into Kg cross multiply, and you will get the vertical moment 488 to 8.878. We have to keep 3 decimal After the decimal, 3 digit. Minus 73.36, minus 72.52, minus 134.28, minus 134.76, minus 58.65. So we get the value 48355.308. So light ship kg is equal to light vertical movement divided by light displacement. So 48355.308 divided by 5499.8. So light ship kg is equal to 8.792 meter. Light ship km find out from the MV hinge ship particulars. Okay, 11.652 meter. So km minus kg is equal to gm. 2.860 meter is our answer. So our next question is, which ship are required to undergo inclining experiment? So all the passenger vessel, irrespective of the size, and the vessel more than 24 meter in length are required to undergo inclining experiment. Okay. Question is second. An inclining experiment was conducted on MV hinge ship with all the tank and compartment empty except 30-ton diesel oil in each 7 port and 7 starboard tank, and also 10 of fresh water in each of twin deck. Drinking water tank port and starboard when the weight of 5.70 ton kg 10.2 meter was shifted transversely through 17.1 a plumb line, deflection 5 centimeters. Calculate the light kg and gm. So generally they are giving the same time, but only they change a little bit value. Okay, so we'll solve 2-3 more questions, and I give you some more the past paper questions, so you can solve and you can write your comment answer in comment box, so then we verified. Okay, so part A I already explained. Passenger vessel in respective of size, and the vessel is 24 meter in length. Now let's move the numerical parts. So what is given in the question? W small 5.70 meter, kg is given 10.2, here D is given 17.10 meter, deflection 5 centimeters is equal to 0.05 meter, plumb length 8 meter. So light ship is equal to 5499.8 ton. Number 7, port and starboard plus 60 ton. Drinking water twin deck, port and starboard 20 tons. The small w is given in the question 5.70 ton. Add all the values. So 5585.5 ton is the final displacement. Okay, now put the value in the formula, the inclining experiment formula. Gm is equal to small w into d, capital D into length of plumb line divided by deflection. .70 into 17.10 into 8 divided by 5585.5 into 0.05. So GM fluid we get 2.792 meter. Now we have to third step I into DI FSC. Now we need to calculate FSM. So 7 port and 7 starboard. 50 into 0.88 and 33 into 0.88. 0.88 is density of fuel and the 50 is FSM. Now add this 73.04. Drinking water tank, port and starboard. 37 into 1 is equal to 37 and 42 into 1 is equal to 42. Add 79. Now the total FSM is equal to, now we have to add both one. 73.04 plus 79 is equal to 152.04. The final FSC is equal to final FSM divided by final displacement. So 152.04 divided by 5585.5. So final FSC is equal to 0.027 meter. Okay, we now find out the final kg. So GM fluid 2.792 meter, FSC 0.027. Now we have to add because we are going to opposite side. 2.819 km we can find out from the MV Hindship particulars for the final displacement, and we get the final kg of the vessel 8.742 meter. Now we need to find out the light kg, so we need to use moment method. Now W is equal to kg into vertical moment. Final displacement 5585.5, kg is 8.742. multiply and we get 48828.441. Now 7 port, final displacement minus 30 ton, kg is 2.62 from the MV Hindship particulars. 7 starboard minus 30 ton, 2.59 minus 77.7. Drinking water tank port minus 10 into 11.19 multiply 111.9. Drinking water tank starboard is minus 10, 11.23 plus multiply 112.3. The small w in the given in the question 5.70, kg is also given in the question, multiply 58.14. Now we get the value 48389.801, and here we get 5499.8 ton. Now the light ship kg of the vessel is equal to light ship vertical movement divided by light displacement. So 48389.801 divided by 5499.8. So light ship kg 8.798. km we can find out from the MV Hindship particulars for that light ship displacement 11.652 meter, and the 2.854 meter is our light GM. Okay, so let's do 2-3 more numericals, then I give you some more past paper question. So now our next question is from the general stability. This question sometimes they give general stability also. If they give the general stability, it's coming for 15 marks only maximum. Okay, a weight of 25 ton is shifted 15 meters transversely across the deck for a displacement 800 tons. causing a deflection of 20 centimeters for a plumb line of length 4 meter. If the km is 7 meter, calculate the kg. Okay, this is also simple. What is given in the question? We have to write small w is 25 ton, d is equal to 15 meter, final displacement is 8000 tons, deflection 20 centimeter, need to convert in meters, 0.2 meters, plumb line 4 meters. Okay, km 7 meters, calculate light ship kg. Put the value in the formula. Gm is equal to W into D upon final displacement into plumb length divided by deflection. 25 into 15 divided by 8000 into 4 into 0.2. So Gm is equal to 0.937 meters. Km is given in the question, 7.000 meter. So light kg is equal to 6.062 meters. Okay, so let's move one more numerical. Our next question is also from the general stability. A ship of displacement 8000 ton, km is 7.3, kg is 6.1 meter. A weight of 20 ton is moved transversely across the deck through a distance of 15 meter. Find the deflection if the length of plumb line is 4 meter. So here we have to find out the deflection. So given in the question is final displacement is 8000 ton, km is equal to 7.3 meter, kg is equal to 6.1 meter, small w is 25 tons, and the d is 15 meters. Deflection we don't know, we have to find out. And the length of plumb 4 meter. Now since we know that Gm is equal to Km minus Kg, so 7.3 minus 6.1 is equal to Gm is equal to 1.2 meter. Now put the value in the formula. Gm is equal to W into D, capital D, into plumb length into deflection. So therefore put the value 1.2 is equal to 25 into 15 into 4 divided by 8000 into deflection. Now cross multiplication, so 9600 deflection divided by 1500. So therefore deflection is equal to 1500 divided by 9600. So deflection we get 0.156 meter, but we need to convert this in centimeter. So 15.62 is cm. This is also from the past MMD paper. Okay, let's move the next question. From an inclining experiment, it was found initial GM is 1 meter and a weight of 10 tons. Shifted 12 meter transversely, a list of 3.5 degree was observed with a deflection of 25 centimeters. Find the displacement and length of the plumb line. Okay, so here two things we have to find out. One is final displacement and one is the length. So we cannot use the find directly to the length because two things is missing. So first we have to find out the final displacement. Okay, since we know that here we have to apply the list formula. Tan theta is equal to W into D upon W into GM. Okay, tan 3.5 degree is given in the question, equal to 10 into 12 W into 1. Now cross multiplication, so 0.061 into W is equal to 120. So therefore W is equal to 1963.99 ton is equal to 1964 ton. Okay, so we find out the final displacement. Now we have to put the in the formula of the inclining experiment. So GM is equal to 110 into 12 divided by 1964 into plumb length we have to find out into deflection 0.25. So therefore 120 into plumb length is equal to 491. Therefore plumb length is 491 divided by 120. Therefore plumb length is equal to 4.092 meter. Okay, so next question is a little bit tricky. It's coming from the Simpson's rule and the combine of inclining experiment. So it's simple. If you see this, I will explain you how to solve. It's very simple. When a weight of 20 tons move 12 meters across the deck of the vessel for which the following data applied. The vessel is inclined 0 degree 24 minutes. Find the kg as inclined if the vessel is floating at even keel draft 8 meters. So even keel draft is 8 meters given in salt water. Underwater volume is 15,000 tons. Underwater volume is meter cube. KB is 4.7 meter. Length of water plane is 120 meters. Half ordinates are follows. So some ordinates value is given 0, 1, 2, 3, 4, 5, 6. Half ordinates is 0, 7, 8, 9, 9, 6, 0. We need to find out the light kg. Okay. So nothing is, this is for generally given for the find out the km. This all this because of we have to find out the km. And what is km? Okay. All this because of km. Km is equal to kb plus bm. What is kb? Kb is equal to draft by 2. Bm is equal to moment of inertia upon v. So all this because of this formula. We have to resolve this one, and then it's normal method what we did earlier. Okay, so let's solve this numerical. Small given, small w is 20 ton, d is 12 meters. Initial list yani inclined 0 degree 24 minutes. Draft in salt water is given 8 meters. Underwater volume is given 15,000 meter cube. KB is given 4.7 meters. Length of water plane 120 meters. So if you see the formula, we need to find out the final displacement. So the final displacement is not given, it's given volume in meter cube. So we know that mass is equal to underwater volume of ship into density. Now underwater volume is 15,000 given into density seawater 1.025. So we get the final mass. That means we get the W. Okay, now we have to resolve this to find out moment of inertia. Because moment of inertia, why we find out? We need to find out the BM. So H is equal to Simpson's rules. H is equal to length of water plane divided by number of ordinates minus 1. Okay, so 120, number of ordinates 7 minus 1, so 120 divided by 6, so H is equal to 20 meter. Okay, now we have to find out the MI, moment of inertia. So half ordinates, system multiplier and product. So half ordinate, write the half ordinates value 0.789960. So it is 7. So 7 apply for both number, Simpson rule number 1 and rule number 2. If you have any doubt in Simpsons, so my videos are for Simpsons for phase 1 and for phase 2 also available in the YouTube, so you can watch. Okay, so Simpson multiplier 1 4 2 4 2 4 1 we used. Now multiply and we get the 0 28 16 36 18 24 0. Okay, now we again write the half ordinates, and this now product and half ordinates we have to multiply, and we get the product which is M3. Now again we have to write half ordinates, and this we have to multiply, so we get the product. So moment of inertia we need to find out the M4. So I escape from this, otherwise you can write the half ordinates and multiply, and but that is useless time. No, you wasting your times. Examination, this is very crucial time in the examinations. So my suggestion is you have to escape. Now what I will do, I will write the system multiplier. So 1 4 2 4 2 4 1, and then cube, ordinates cube. If you do the other method, the value will be coming same. Okay, which method you comfortable, you can do that method. 0 multiply 1372 1024. If you have still any doubt, write me in comment box. Okay, so we add all these values 7634. This is only half ordinates, and this is 122. SOP1 is, you can say SOP1, and this is SOP4. So moment of inertia is equal to H by 3 into SOP1 SOP4 into 1 by 3. Okay, since this is half ordinates, so into 2 for full ordinates. H by 3 is find the area. So H is, we calculate 20 by 3 into 7634 into 1 by 3. When we can calculate moment of inertia, we need to use 1 by 3. Okay, into half ordinates का फॉर्म को फुल करना है तो into 2. So moment of inertia is equal to 3392.888 m to the power 4. So Pm is equal to Mi upon volume 3392.888. Volume is 15,000 given in the question. So we find out 2.262 meters. So if you see, all the Simpsons is used for only calculating the Bm. Now after Bm, everything become normal. So Km is equal to Kb plus Bm. So 4 Kb is given in the question plus 2.262 Bm we just find out. And we find out that Km is 6.962 meters. Okay, so tan theta is equal to W into D upon final displacement. Now tan 0 degree 24 minutes given in the question, 20 into 12, Final displacement we find out into GM, we don't know, so we need to find out GM. So 107.339 into GM cross multiplication, and we get the GM value 2.236 meter. KM we already know, 6.962 meters. So kg light of vessel 4.726 meters. This is our answer. Okay, so this is only the difficulties you need to find out the PM, and it's also simple. If you see my Simpson video, you will clear your doubts. Still, if you have doubt, write me in comment box. Okay, so we'll solve one or two questions for the past paper MMD for the MB headship. Then I will give you some homework so you can solve also. So this is, if you see, this question is coming question number 1. That means coming in part A also. So MB headship was floating with all compartment empty except as follows. Number 2, port and starboard DB tank full with water ballast. Number 1, DB tank contain 100 tons of HFO. There is, in the question is, there is correction. HFO is given value 0.95 and FSM is given 419. So in this question there is a correction. An inclining experiment was conducted in this condition. A weight of 10 ton kg 10.2 shifted transversely through a distance of 17.6 meter. Caused a deflection of 8.3 centimeters. So we need to convert this into meters. Plumb line is 8.5 meters in length. Calculate the GM solid and the kg of the light sheet. As earlier we solved this type of numericals, but we have to solve 2 more so that you will more comfortable. Okay, so W small is given 10 ton, kg is equal to 10.2. so if you can see without looking, you can solve and you can compare your answer with this video so that you will be comfortable and more confidence during the examination. .083 meters. Plumb line 8.5 meter. If you like this video, please share your friends, subscribe. Okay, light ship kg, light ship displacement we get from the MB ship particular condition. Number 1, 1499.8. Number 2, dB port and starboard 202.4 into 1.025 is equal to 414.92. Number 1, dB is equal to 100 ton. Small w is given in the question 10 ton. Now we have to all add and we get the final w, which is 6024.72 tons. Now we'll go to the second step. We have to find out the GM. So write the value formula of the GM: W into D upon final displacement into length of plumb line divided by deflection. Find the GM. 10 into 17.6 divided by 6024.72 into 8.5 divided by 0.083. So we get the GM 2.992 meter. Now the third step, we have to find out the FSM. So number 1, dB tank, maximum capacity. Okay, we have to find out the maximum capacity in the ambient ship particulars, where is 100% is given. We have to find out their value, and then this multiplied by the density 0.95, we get the total mass we can occupy. This all we learn in the second map. Still any doubt? If you want video, write me in comment box. So FSC is equal to FSM upon final displacement. So 419 into 0.95 into 6024.72. So we get 398.05 divided by 6024.72, and the FSC we get 0.066 meter. GM fluid we calculated just now, and FSC have, so we have the GM solid add 3.058 meter. KM from the MV heatship particulars for the final displacement, and kg final kg 8.055 meter. Now we have to find the light ship kg, so we have to go by moment method. Okay, now W, kg and vertical moment. Final displacement 6024.72 is kg is, just find out, 48529.119 cross multiply number 2 dB, port 207.46, number 2 dB, starboard side 207.46, number 1 dB, 110, small w 1010, and it should be equal to light ship, correct. Now put the value of the kg of the all compartment which we find out which we get from the MV heatship particulars. Okay, multiply and we get 134.85, 134.85 minus 114 minus 102, final is 48043.419. Now the light kg, light vertical movement divided by light displacement, so light kg is equal to 8.735 meter. Light km from the MV heatship from the hydrostatic table. Okay, or you can find out also the condition number 1, the km value 2.916 meter, our answer. Okay, this is also May 16. So I cover from the 2023 November 23 and May 16. So you don't need to go to verify this from the MMD paper. You can solve this all and you can practice. I give you some more which is similar but change the value here and there. So if you give 1 hour, your 25 marks is clear. Now I will also make video for SFBM paging. So you give around 2-3 hours, or maybe within 1 hour you give for stability Naval Arc. You will easily score by watching my video is 75 to 80 marks. And then regarding left is you have to this cross section question number 4 and little bit theory. So it 50% is passing marks, so you can easily clear. Okay, let's final this my final question for this video, so that video is not so big. Okay, so given is the question, given in the question is W is equal to 12 ton, kg is equal to 10.1, d is equal to 17.5 meter, deflection 8.2 centimeters, we need to convert into meters, and plumb line 8.1 meter. As first step we have to find out the final displacement. So light ship 5499.8 from condition number 1, number 2 dB, port and starboard. So 202.4 into 1.025 is equal to 414.92 tons. Number 1 dB is given 90 tons. Small w is given 12 tons. All we have to add and we get the final displacement. The second step, we have to find out the GM fluid. Okay, so GM is equal to W into D upon capital D into plumb length into deflection. So GM is equal to 12 into 17.5 divided by 6016.72 into 8.1 divided by 0.082. So GM fluid is equal to 3.448 meter. Now third step, we have to find out the FSM. Number 1 dV 419 into 0.95 is equal to 398.05. Now FSC is equal to final FSM divided by final displacement. 398.05 divided by 6016.72 is equal to 0.066 meter. GM fluid 3.448 meter, FSC 0.066 meter. Add and we get the GM solid 3.514. Km from the ambient ship particulars. kg we have to find out. Final. Now go to moment method. We need to find out the light kg. (769.189) minus 414.92 minus 90 minus 12. So we get the light shift 5499.8. Put the value 0.65, 1.14, 10.1, multiply 269.69 minus 102.6 minus 121.2. We get 45275.699. Light kg is equal to light vertical movement, light displacement. So 45275.699 divided by 5499.8. So light kg is equal to 8.232 meter. Light km from the ambient ship particulars we have to find out. Or condition number 1 you also get. So light GM, which is required by this ANS question. Okay, so if you see this all the past paper, so you can solve and you can write me your comment box what is your answer, so then I can verify your answer. This is all 25 marks and very simple. If you see my video 1 hour, you will easily get 125 marks. Then you need to only score 75 marks also, so clear this exam. So hope you understand this inclining experiment numericals and the theory part also. Still, if you have doubt, write me in comment box. Best of luck for your examination and see you on the next video. If you like this video and it's useful for you, please also write me in comment box, so that this is help me to appreciate. Thank you, have a good day and best of luck.